Image explanation, position of IP in TCP IP protocol suite. This image shows the 5 layers of the TCP IP model and which protocols work in each layer. 1. Physical layer. What it does, sends actual electrical signals, light pulses, or radio waves through wires or wireless. Example, Ethernet cables, fiber optics, Wi-Fi signals. 2. Data link layer. What it does, transfers data between two devices in the same network using MAC addresses. In the image, LAN/WAN technology works here, like Ethernet or Wi-Fi. 3. Network layer. What it does, decides how to send data across networks from source to destination. Protocols here. IPv4 main protocol that carries data packets across the internet. ICMP sends error messages, e.g., destination unreachable. IGMP used for managing groups for multicasting. ARP converts IP addresses into MAC addresses. 4. Transport layer. What it does, delivers data from one application to another, reliably or quickly. Protocols here. TCP reliable, ordered delivery used for websites, emails. UDP, fast but unreliable, used for videos, games. SCTP supports multi-streaming and better error handling, used in telecom. 5. Application layer. What it does, provides services directly to users or software. Protocols here. SMTP for sending emails. FTP for file transfer. TFTP, lightweight file transfer. DNS converts domain names to IP addresses. SNMP for managing networks. BOOTP for booting a computer over a network. Summary. IPv4 is part of the network layer, which helps route data across the internet. Each layer adds its own protocols and functions to make data travel from sender to receiver. This model helps computers communicate clearly and efficiently over networks. IPv4 Header Format. When a data packet is sent over the internet using IPv4, it carries a header that contains important information for delivery. This header is 20 to 60 bytes in size and contains various fields. This image shows the structure of an IP datagram, which is the basic unit of data sent over the internet using the IP, Internet Protocol. Let's break it down. IP datagram structure. 1. Header, 20 to 60 bytes. This is the starting part of the IP datagram. It contains important information like sender and receiver IP addresses, packet size, fragmentation info, time to live TTL, protocol TCP UDP. The size of the header can be between 20 to 60 bytes, depending on how much extra info is added. 2. Data payload. This is the actual message or content you want to send. The size of data depends on the total size of the datagram. The total size of the datagram, header plus data, can range from 20 to 65,535 bytes. Summary. The header equals like an envelope with address and instructions. The data equals the actual letter inside the envelope. Minimum size, 20 bytes, only header. Maximum size, 65,535 bytes, header plus data. This image shows the IPv4 header format, which is the structure of the header part of an IPv4 packet. The header contains essential information about how the data should be delivered. Let's understand each field. 1. Version 4 bits. Tells which IP version is used. For IPv4, this value is 4. 2. HLEN. Header length, 4 bits. Tells how long the header is. Measured in 32-bit words. Minimum is 5, i.e., 20 bytes. 3. Service type, 8 bits. Also called type of service, TOS. Used to define the priority of the packet, like urgent or normal. 4. Total length, 16 bits. Total size of the entire packet equals header plus data. Maximum size is 65,535 bytes. 5. Identification, 16 bits. Used for uniquely identifying each packet of data. 6. Flags, 3 bits. Controls fragmentation. Helps determine if a packet can be broken into smaller parts. 7. Fragment offset, 13 bits. Shows the position of a fragment in the original data. Used when large packets are broken into smaller ones. 8. Time to live, TTL, 8 bits. Limits how long the packet should stay on the network. Prevents infinite loops. 9. Protocol, 8 bits. Tells which protocol is used in the next layer, e.g. TCP equals 6, UDP equals 17. 10. Header checksum, 16 bits. Used for error checking the header only. If an error is found, the packet is discarded. 11. Source IP address, 32 bits. IP address of the sender. 12. Destination IP address, 32 bits. IP address of the receiver. 13. Options plus padding, 0 to 40 bytes. Optional field, used for extra features like security or timestamps. Padding is used to make sure the header ends at a 32-bit boundary. Summary in one line. The IPv4 header tells routers how to handle, route, and deliver the data safely and correctly. Next video, Video 6, IPv6 Header Format. Learn how the IPv6 header is structured and how it's different from IPv4.